Hello everyone, I'm SJBIT, working as Assistant Professor in the Department of PC SJBIT. In this lecture, we'll be discussing about computer organization and architecture.
So let us discuss on the memory locations, address and operations. Memory location, address and operations. So what is a memory? Memory, it is going to store a 1 bit memory cell which is going to store a 1 bit of data. So memory consisting of many millions of storage cells and each of which can store 1 bit. So the data is usually accessed in the n bit groups, that is n is called the word length. So this is going to be considered as the topmost level if it is considered as the first word, and the second for it considered as the second word. In that manner, it is the ith word, and the last is considered as the last word. So here the memory consisting of millions of storage cells, each of which can store a bit of information having the value of zeros or 1. Because the single bit represent very small amount of information that is usually approached to deal with them in the groups of fixed size. So memory is organized in a group, that is n bits can be stored or retrieved in a single basic operation. Each group of n bits is referred as the word of information and the n is called the word length. So the memory of a computer can systematically represented as a collection of words. So as shown in the figure here, so the modern computers which have the word length which is typically varied from the 16 to 64 bits. So the word length of computer is 32 bit. A single word can store the 32 bit of data. So the twos complement number are for 4 ASCII characters. So each ASCII, occupying the 8 bit. So a unit of 8 bits can considered as a byte, which missions instructions may require one or more words for their representation. So accessing the memory to store or retrieve the single item of information, either a word or a byte, requires the distinct names or the addresses for each item location. So to use a number from 0 through 2k minus 1 for some suitable value of k. So the address of successive locations in the memory, the 2 to the power of k addresses constitute the address space of the computer, and the memory can have up to 2 to the power of k addressable locations. So example, if I say 24 bit address generate the address space, 2 to the power of 24 is nothing but 16 lakh 770 77,216 locations will be there. So this number is usually written as the 6M, 16 mega. So 2 to the power of 20 is nothing but 1 mega. Similarly, 2 to the power of 32 is nothing but 4 giga. 2 to the power of 30 is nothing but 1 giga. So let us know one by one. So what is byte addressability? So this is what the memory location and address and operations. So 0 to 0 bit is going to be the first, it is the positive numbers, and 0, 30, B of 31 is equal to 1 is nothing but the leftmost bit will indicate the positive or the negative numbers. So 8 bits which represent the ASCII characters, and another 8 bit is represent the 8 bits, and 8 bits and represent the each ASCII character which requires the totally it is of 32 bits which is going to represent the 4 ASCII character. So memory location, address and operations. So to retrieve the information from the memory, either the one word or one byte address for each locations are needed. As I mentioned, the k bit address memory has 2 to the power of k memory locations. So namely 0 to k minus 1 is called the memory space. So 24 bit to the power of 24 bit, as I mentioned, it is going to be considered as one that is 16 megabytes of memory. So 2 to the power of 20 is nothing but 1 mega. 2 to the power of 32 is nothing but 4 giga. Similarly, 2 to the power of 30 it is considered as the 32 is considered as the 4 giga. 2 to the power of 30 is considered as the 1 giga. So it is impractical to assign the distinct address to individual bit locations in the memory. So most of the practical assignment is to have the successive addresses referred as the successive byte locations in the memory, and the byte addressable memory, and the byte locations have the address of 0, 1, 2 if the word length is of is 32 bit, and they have successive words are located at the address of 0, 4 and 8. So there are two types of addressing. One is the little Indian and the other one is the big Indian. In the earlier what we discussed is the assignment in the most modern computer, and it's one of the that is known as the byte addressable memory is used for this assignment. So the byte locations have the address of 0, 1, 2, 2. If the word length is machine is 32 bit and the successive words are located as 0, 4, 8 with the each word is consisting of the 4 bytes. So another addressing scheme is nothing but big Indian and the little Indian. There are two ways that a byte address can be assigned to across the world. That is, the name big Indian is used for the lower byte address. We are used for the most significant bytes of the word, and the name little Indian is addressing for the opposite ordering, where the lower byte address is used to the less significant bytes of the word. So the word more significant or less significant are used to the relation of the bytes. So assigned to bits when the word represent a number. So both the little Indian and the big Indian assignments are used in the commercial machines. So byte addresses are 0, 4, 8 are taken as the address of the successive words in the memory, and are the addresses used when the specifying the memory read or any read and write operations. So in addition to specifying the address ordering of the bytes within the word, it is also necessary to specify the labeling of the bits within a byte or word. So the most common and convention method and one of the easiest method, it is the as shown in the figure, that is the big Indian assignments. So which is the natural ordering for the encoding the numerical data. So the order also the labeling bits within a byte, that is the B7 to B0 from the left to right. There are the computers. So going to use the big Indian and the little Indian assignments. So next is the memory locations address and operation. Under this the addressing of ordering address ordering of bytes. So the word alignment. In word alignment, the words are said to be aligned in the memory if they are begin to byte address, that is a multiple of the number of bytes in the word. 16-bit word are word addresses, that is 0 to 2 and 4. 32-bit it is 0, 4, 8, and 64-bit word it is 0, 8 and 16. So next it is the accessing numbers and the character strings. So in accessing number in the character strings, that is going to use it as load. Load is nothing but the in many applications, it is necessary to handle the characters of strings variable length, and the beginning of the string is indicated by giving the address of the byte containing the first character, and the successive byte locations contain the successive characters for the string. There are two ways of indicating the length of the string. The special control character with the means end of the strings can be used to the last character of the strings to, or to separate the memory word location, or the processor register can contain the number of indicating the length of the strings in the bytes. So next is the memory operation, where the load is nothing but load or read or fetch, both are the similar terms. Copy the contents of the memory. So the when it is going to copy, the memory contents are not going to change. So next is the address. It can be address, load the address, register can be used to store or write. Overwrite the content in the memory, address and the data stored, and the registers can be used to store the data. Here the content of the memory is getting changed. So next is the instruction and instruction sequencing. So here you are able to see there are four types. One is the data transfer. There are data transfer between the memory and the processor register, arithmetic and the logic operations on the data, programming, squeezing and control, and IO transfers. So let us discuss one by one. So the first one is the register transfer notation. So you are able to see that identify the location by a symbolic name standing the hardware binary address, that is a location comma or not. The content of the locations are denoted by the placing the square brackets around the name of the location, that is the location LOC is moved to the register R1. So this can also be written as the location of R1 plus R2, the content is getting added and that is shifted to the register R3, and this is known as the register transfer notation. So next is the assembly language notation. So here you are able to see that in assembly level language that represent the machine instruction and program. So that is move location R1 is equal to, that can be written as the location of the content, memory location will move to the R1. So add R1 comma R2 comma R3 is nothing but R1 and R2 is getting added and it's been given to the register R3. So here, so the assembly language format, an instruction that causes the transfer described in the slide from the memory location LOC to the processor R1 and specified by the statement it as move LOC comma R1. So this is about the assembly language notation. So next it is the CPU organization set of instructions. So it is a single accumulator. So which results may goes to the accumulator, or accumulator has to save the memory quite often, because in CPU there is a separate unit. It is known as the accumulator, which is going to do which is going to accumulate all the results. We usually represent it as the A. So the result is usually goes to the accumulator, and accumulator has to be saved into a memory quite often. So this is about the register set and the memory location in case of the computer systems. Uh, so next video we may discuss upon many more instruction sets. Thank you.